A proton with a mass of 1.67 times 10 to the power of negative 27 kilogram is moving horizontally eastward at 9.4 times 10 to the power of 4 meters per second as it enters a magnetic field of strength 1.8 Tesla. The field is directed vertically upward. Calculate the magnitude and direction of the magnetic force on the proton. Determine the gravitational force on the proton, and determine the ratio of the gravitational force to the magnetic force on the proton. So the first thing I'm going to do the part A. Part A is saying that find out the direction and magnitude of magnetic force. F will be BVQ times sine theta. F is the magnetic force in terms of Newton. B is magnetic field strength in terms of Tesla. V is velocity of the charged particle. Q is the charge of the particle, and sine theta, theta is the angle between the velocity vector and the magnetic field, which in this case is going to be 90 because they are perpendicular, and sine 90 is 1. So F equals to BVQ in this case. B is given magnetic field strength 1.8 Tesla. V is given velocity 9.4 times 10 to the power 4, and we have charge for proton is 1.6 times 10 to the power of negative 19. Sine theta is 1. So we have 1.8 times 9.4 times 10 to the power of 4 times 1.6 times 10 to the power of negative 19. That's going to give me 2.71 times 10 to the power of negative 14 Newton. Now, find out the angle. For angle, you need, for direction of the magnetic force, we need to use the right hand rule. When thumb is going toward velocity and four fingers showing the magnetic field direction, which is going up, and then the palm of the right hand is gonna show you the direction of the force, which in this case is gonna come out of the page. So it is gonna come out, and I can show it. It is gonna be like that, and it's gonna say out of the page. Part B, it says find out the gravitational force on proton. F equals to ma. We are dealing with gravitational force. Before it was magnetic force. Gravitational force is going to be m. Mass is given 1.67 times 10 to the power of negative 27. And a is going to be the gravitational acceleration, which is 9.8. That will be 1.64 times 10 to the power of negative 26 Newton. And part C, it says determine the ratio of gravitational force to the magnetic force by a proton. Part C, it says determine the ratio of the gravitational force to the magnetic force on the proton. So it is going to be Fg over Fm. Fg is 1.64 times 10 to the power of negative 26 divided by f of m, 2.71 times 10 to the power of negative 14. So that's going to be 1.64 times 10 to the power of negative 26 divided by 2.71 times 10 to the power of negative 14. That will be 6.05 times 10 to the power of negative 13. That's going to be the ratio. It means that gravitational force is much smaller than the magnetic force for this case.